Okay, now we're on unit 4, so we're going to be on number 61. It says, let W be the differentiable function such that W of t equals the amount of water to take in gallons after t hours, and we need the best interpretation of W prime of 4 equals 3. So for this, I like to look at the units and make a note of that. So if WT equals, it's going to be our gallons. We know that W prime of t should be adding a rate, so it should be gallons per hour. So looking at my answer choices now, let's just see which ones we can get rid of. So A is the amount in gallons. That cannot be the right answer. The amount of water increasing at a rate of 3 gallons per hour. That one works. The rate of change is increasing at 3 gallons per hour, so that one's good. D says gallons. So if we think about this, let's look at the words that are in these sentences. So both of the units are good on B and C, but let's make sure that the number of rates that we're talking about matches. So this is really just one rate. So we should be counting the words that mean rate and seeing how many that we have. So the word increasing at a rate, that's 1. C says the rate of change is increasing at a rate. That's 2 rates, which does not match since we only have W prime instead of W second derivative. So B is going to be our answer here. Okay, 62, we're going to do the same thing. So I'm going to start by just looking at units. So we know A of t is acorns per year. And we're worried about A prime of t. All right, so now if it says acorns per year, we're adding another rate. It's going to be acorns per year per year. So we're starting off, A of t is 1 rate, which means A prime should be 2 rates. And then looking at this, we know that it's going to be something about it being positive. So the number of acorns produced is positive. A has 0 rates, when really we want 2 rates, so it can't be A. The number of acorns produced is increasing, so that's going to be 1 rate. Still not the right answer, because we need 2 rates. C says the rate at which it's produced is increasing. That's 2 rates, so maybe. And D is talking about the average number of acorns. We know nothing about an average number here, so it's not D. The answer is C. It matches exactly what this is saying because it's increasing. That's why it's greater than 0. All right. If R of t equals t cubed, represents the number of rhinos that are in the forest after 2 years, what is the rate of change of the number of rhinos in the forest after 2 years? So the fact that we only have 1 rate means I need to take the derivative 1 time, which would be represented by 3t squared. And then we're just looking for r prime of 2. And if we simplify that, we get 3 times 4, which is 12. So C would be our answer. Okay. P of t we know is going to be pineapples per week. Which is 1 rate. And we're looking for which statements the number of pineapples being shipped is increasing at t equals 4. So all this is, it's asking about 1 rate. We just need that 1 rate to be increasing. So since P of t is already a rate, we don't need to take a derivative of it. And to show that it's increasing, it just needs to be greater than 0. So if that rate is greater than 0, that means the number of pineapples being shipped is increasing. So our answer would be A. All right, W of t is a differentiable function, represents the rate at which water enters a tank. R represents the rate at which water is being removed from a tank. So which of the following would represent the rate of change of the amount of water is decreasing at t equals 1 day? All right, so basically we need to look here and decide what is the rate. So let's just go ahead and write down what everything is. So W of t, we know it's when it's entering the tank. And then it tells us it is gallons per day. And then we have R of t, which is going to be what it is, where is it? Removed. And then removed is going to be, where is it? Also gallons per day. So we're trying to see which of the following expressions would represent that the rate of change of the amount of water is decreasing at t equals 1 day. So here we have 1 rate, here we have another rate. So really we're looking for 2 rates. Now WT and R of t are already rates, so we need to take the derivative again. So really we should be dealing with R prime of 1 W prime of 1 and R prime of 1. So really we need to take the rate that the water is entering, subtract the rate which it's leaving, and if it's decreasing, we want it to be less than 0. So D would be our answer. So the key to these is counting the number of rates that we have. Okay, so this graph gives us velocity, and we want to know where the particle is moving left. So right away you should think velocity left, meaning the particle is moving left, or the position is left. Velocity should be negative. So the places where this graph is negative is from 0 to 4 and 7 to 9. Since this is the graph of velocity. So particle moving left means velocity is negative. The answer is D. All right, 67, particle moves along the x-axis and its velocity is given by 2t squared minus 6t. What describes the motion of the particle at t equals 1? So motion of the particle, meaning speeding up, slowing down is what all these are asking for. So we know we need to find the velocity of the particle at 1, which is 2 times 1 squared minus 6 times 1, is going to equal 2 minus 6, which is -4. And then we got to find the acceleration. So our acceleration equation is 4t minus 6. So I plug in a 1, I'm going to get 4 times 1 minus 6. It's -2. So based on this, we can see our velocity is negative and our acceleration is negative. So this is going to tell us that it is speeding up because velocity and acceleration have the same sign. So your answer here would be A. Okay, this one wants to know when the particle is at rest, but it gives us position. So I need to find velocity by taking the derivative. Derivative of cosine is negative sine t over 2. But because of chain rule, I multiply this by 1/2. So v of t equals negative 1/2 sine of t over 2. And then I need to figure out where this is going to be equal to 0. So I have 0 equals negative 1/2 sine of t over 2. Then I can multiply this by negative 1/2, and it stays 0 equals sine of t over 2. So now I need to figure out where would this end up being equal to 0. So if I think about my unit circle, I know sine is 0 over here and over here. So if I plugged in a 0 here, I'd have sine of 0, which equals 0. So I know 0 has to be one of my answers. So I can get rid of D, and I can get rid of C. So that leaves me with A and B. I just need to figure out what would happen if I replaced t with 2 pi. So if I did that, I'd get sine of 2 pi over 2, which leaves me with sine of pi, which is this one over here. Sine of pi is also 0. So B is our answer. Okay, next we have position equals e to the 2t minus 1. And we want to know what the acceleration is, so I need to take the second derivative. So my first derivative gives me velocity. Derivative of e to the 2t is 2e to the 2t. Then acceleration is going to be a derivative again, so 4e to the 2t. Then I just plug in 0. So 4 times e to the 0, that becomes a 1. Your answer is 4, because e to the 0 equals 1. Okay, here we have velocity again, and they want to know where it's at rest. So basically, we need to figure out where does this graph hit 0, because when v of t equals 0, that's when it's at rest. And we can see that happens at 3 and at 6. Your answer is C. Okay, so on this one, we have a velocity graph, and it wants to know where the acceleration of the particle is negative. So if we think about velocity, that's what our graph is. I like to think of these as maybe f and f prime. So let's say that velocity is really like our f prime graph. And it wants to know if we did this. So we're trying to figure out when the acceleration is negative. So that's really like our second derivative. Well, we know that means f prime is decreasing. And we know that's when f is concave down, which doesn't really mean much to us with PV. But this is like my acceleration. This is my velocity. So if I went when the acceleration is negative, that means my velocity has to be decreasing. So notice it's going to be decreasing from 0 to 3, and then again from 5 to 7. So our answer for that one . 72. So here we have related rates. So they give us the block, they give us volume, and they want what is the rate of change of the side length of the cube with respect to time. So all we're going to do here is we're essentially going to take the derivative of this. So I'm going to have dv dt equals 3s squared, and then remember you have to write ds dt. So it tells me a bunch of things. So the things that I know is that s equals 2. The volume is decreasing, so dv dt equals -5. And then I need ds dt. So all I have to do is plug in everything that I know. So -5 equals 3 times 2 squared ds dt. Then if I simplify this, I get -5 equals 12 ds dt, divide by 12. So our answer is A. See, not all related rates problems are terrible. 73 is very similar. So we have the radius of a circle is decreasing. What is the rate of change of the area of a circle? So that's going to be the formula we're using, pi r squared. And once again, let's just go with a know and need. So the things that I know, the radius, so dr dt, decreasing, so it's going to be -2. And then it tells us the radius equals 5. And I'm looking for dA dt. So I take the derivative, I get dA dt equals 2 pi r dr dt. Then I just plug everything in, so dA dt equals 2 pi times 5 times -2. And if you simplify that, you should get -20 pi, or B. Okay, 74. We have a tangent line. We're trying to estimate. So the first thing I need, I'm going to need an x value, a y value, and a slope. So the x value I know they give me is 3. Then I can find my y value by just plugging it in. And I get natural log of 1, which equals 0. So my y value is 0. Then I need to find my slope. So the derivative of natural log I know is 1 over 2x minus 5. But because of chain rule, I need to multiply that by the derivative, which is just 2. So f prime of 3 is going to be 1 over 2 times 3 minus 5 times 2. which equals 1 over 6 minus 5 is 1. So 1 times 2 equals 2. So my slope is 2. Then I have my tangent line, so y minus 0 equals 2 times x minus 3. Then to estimate 3.5, I just plug it in, so y equals 2 times 3.5 minus 3, which is y equals 2 times 0.5, which has to equal 1, which our answer is B. All right, 75. Same kind of thing, except they pretty much give us all of our information. So we know that we have y minus 3. Slope is negative 4. And then we're trying to approximate 2.1. So y minus 3 equals negative 4 times 2.1 minus 2. Y minus 3 equals negative 4 times 0.1. So that's going to equal negative 0.4. When I add 3, I'm going to end up with 2.6, or A. Okay, next one, we want the limit as x approaches 4 of f of x over x squared minus 16. So if you plug in 4 here, notice this gives you a graph of f. If we look at 4, it's 0. So we're going to end up with 0 over 0. So we have to use L'Hopital's. F prime of x over 2x. So I took the derivative of the top and the bottom, and now I'm going to try plugging it in again, which gives me f prime of 4 over 2 times 4, which is 8. And I just need to find the slope here. So down 1, 2 over 2. Looks like my slope is negative 1 over 8, which is my answer, C. Same thing's going to happen with 77. When you plug it in, you get 0 over 0, which is an indeterminate form. So I'm going to use L'Hopital's here. So our limit becomes the limit as x approaches 2. Derivative of sine of x minus 2 is cosine x minus 2. Derivative of the bottom is just 2. So when I plug it in, we get cosine of 2 minus 2 over 2. And cosine of 0 is 1, which makes our answer B, 1/2. All right, 78. So this one tells us f of x equals natural log of x, and the limit as x approaches infinity for g of x is infinity. So obviously if we plugged in infinity here, I'm going to go ahead and replace f of x with natural log of x. When you plug that in, you're going to end up with infinity over infinity, which is an indeterminate form. So I can take the derivative of the top and the bottom with L'Hopital's, and I get 1 over x over g prime of x. And then when I plug it in, so I have 1 over x on top, so we know that we're replacing that with infinity over g prime of x. So as this goes to infinity, it's going to end up with 0 over, they tell us g prime has a horizontal asymptote at y equals 4. So as x approaches infinity, g prime is going to approach 4. But not that that matters, the top is 0, so our answer is 0. Okay, 79 wants to know which of the following is equivalent. So this is basically L'Hopital's. We're going to take the derivative of all our answer choices to see which one matches what they gave us. So the derivative of A is 2x over 2x minus 1. That doesn't match, not the answer. B is going to be 4x over 2x minus 1. Not the answer. C is going to be 2x over 4x minus 1. That is our answer. If you did the same thing for D, you'd get 4x over 4x minus 1. Not D, it's C. Okay, a single application of L'Hopital's can be used to evaluate which of the following must be false. So if we look at this, we know that both A and B have to be true, because if we plug these in order to use L'Hopital's, you have to end up with 0 over 0. So that means f of x and g of x both have to be 0. Now if I take the derivative using L'Hopital's, you should end up with f prime of x over g prime of x. Now one of these is acceptable to be 0, and that's f of x. It's allowed to be 0. But g prime of x, that cannot be 0.